Good morning, students. In the last class, we discussed about the scientific notation, right? And how we are going to calculate the scientific notation, how we are going to represent the numbers in the form of a n into 10 to the power of plus or minus n. So in that addition and subtraction and multiplication of this scientific notation is also there. Okay. So remember, I will say addition first. Okay. Students, for addition, I'll take two numbers. 20.08 into 10 to the power 2. Okay. This is one. Next, 1.50 into 10 to the power of 2. Okay. So we have to do what? Addition for these two. Okay. First you try to add the students. Remember, for this addition, you have to see these powers must be same. Powers must be same. If instead of this, listen, if it is 10 to, it is like 200.8. Okay, two numbers I'll take for addition, 200.8 and 1.50 into 10 to the power 2. Two numbers are there. So this is a 200 point number, it is in 10 to the power of plus 2. Okay, so for addition, subtraction and multiplication, so multiplication and division won't require this type of powers, must and should be same, but for addition and subtraction the powers must be same. Understand? Because you have to take them as a common factor. Here it is 200.8 plus 1.50 into 10 to the power of 2 is there. Okay, so this is converted to this power. We want 10 to the power 2. That is 1, 2. Okay, that is 2.008 into 10 to the power 2 plus 1.50 into 10 to the power. So among these two, 10 raised to 2 is the common factor. Okay, that is 2.008 plus 1.50 into 10 to the power 2. Okay, so 2.008 and 1.50 is 3.508 into 10 power 2 is the answer. Understood? So the powers must be same. So another one example I will say for the same addition. 2.7 into 10 to the power of minus 3, 5.2 into 10 to the power minus 4. Addition for these two. Understand, students? We have to add these two numbers. So as I told you, the main thing for this addition is what? The powers must be same. Okay? In the same number, I will show you what is addition, what is subtraction, what is multiplication and division. Okay? So take 0.7, 5.4 you take. For division, multiplication, it will become easy. So students, this one for addition means here 10 raised to minus 4 is there, here 10 raised to minus 3 is there. Either you convert this to 10 raised to minus 4 or you convert this to 10 raised to minus 4. Are you getting? Either you convert this to 10 raised to minus 4 or you convert this term to 10 raised to minus 3. So you have to convert this to 10 raised to minus 3 means it is multiplied by 10. Then what? Here 10 to the power of 1 means this is minus 4 plus 1, that will become minus 3. If bases are same, powers are added. Correct? If it is multiplied by 3 means this will become what? 54. 54 into 10 to the power minus 3. Understood? Either this term be like first one 2.7 into 10 to the power minus 3 plus 54 into 10 to the power of minus 3. This one possibility. Another one, convert this to 10 to the power of minus 4. That means this is multiplied by 10 to the power minus 1. That means what? Divided by 10. Plus 1 means multiplied by 10. Minus 1 means divided by 10. Understood? That means this term is divided by 10. That means what? 0.27 into 10 to the power of minus 4. Remember one thing, students. If you want to increase minus values, these powers should move backward. 0.27 into 10 to the power of minus 4. If you increase minus value. Okay? If you want to decrease the minus value, this should shift forward. Listen, 5.4 10 raised to minus 3. If it shift one forward means 54 into 10 to the power of minus 3. And minus 4 is there and minus 3 is there. Okay? Next. Here it is 5.4 into 10 to the power minus 4. Understood? If you do, you'll get the correct answer, either by addition or subtraction. So if you add this, you'll get the same. For minus also, it is same. Power should be same for plus as well as minus. Okay. Next, multiplication means these powers, whether it is same or not, we don't bother about that. Understood? If it is same or not, we won't bother about that. Are you getting? So that means what? Here it is 2.7 into 5.4 into 10 to the power minus 3 into 10 to the power minus 4. If bases are same, powers are added, that is minus 3 minus 4 become 10 raised to minus 7. So the answer of these two into 10 to the power of minus 7 is the answer. For division, if you take same, that is 2.7 divided by 5.4. Here it is 10 raised to minus 3 is there. Here it is 10 raised to minus 4 is there. Okay. Remember students, if the term changes from numerator to denominator or denominator to numerator, the sign of the power will change. Are you getting? Here 10 raised to minus 3 is there. It is in numerator. If we consider it, if we changes the position from numerator to denominator, from minus 3 it becomes plus 3. Okay. Here 10 raised to minus 4 is there. It is in numerator. If we convert numerator to denominator, interchange the place means it become what? Plus 4. That means this become what? 2.7 divided by 5.4 into 10 to the power of minus 3. It is in the same position. So it is taken to numerator means 10 to the power plus 4. Are you getting? If the position of these changes from numerator to denominator, denominator to numerator. Okay, then the sign of this changes. If we are already a plus 4, then it is changes to minus 4. Okay, this is only possible in what? Division. In multiplication, it is as it is. The powers are added. Then, now here bases are same, then powers are added. Minus 3 plus 4 means, of course, it is plus 1. And that is 2.7 divided by 5.4 into 10 to the power 1. Correct? So this will get cancelled by 1 by 2, that is 0.5 into 10 means that is 5. This is the way to do multiplication, subtraction, division and addition. So for addition and subtraction, the thing you have to remember is the powers must be same like this. Powers must be same. For what? Addition and multiplication. Sorry, addition and subtraction. Because if the powers are same, then only they represent what? Their perfect places. You know, unit position, tenth position, 100, 1000, 10,000. So this powers tells about the position of the numbers. Understand? Always subtracting, how can you do? If here 5, 2, 3, 6 is there, 2, 3, 4, 5 is there, unit place is subtracted by unit place only. 10th place is subtracted by 10th place only. Right? And 100 place is subtracted by 100 place only, and 1000 is subtracted by 1000 only. You cannot subtract this 1000 by unit place. So that's why these powers, why these powers must be same means they exactly tells about the position of the numbers. At which position they are. Understood? For addition also same, always unit place, 10, 100, 1000 places. Same places to be added, same places to be subtracted, right? So that's why the powers must be same. For multiplication, we don't know. Okay? So this is all about the addition, subtraction, multiplication and division in scientific notation. So the next term for you is, students, precision and accuracy. Precision and accuracy. Okay, so the next terms is precision and accuracy that tells about especially significant figures. Significant means important. Okay, if any term is there in that, which one is considered as a significant, as it is correct for that respective value. So before going to significant figure, I'll say precision and accuracy. Okay, so what is precision means, students? So precision is the closeness between the values. Precision is the closeness between the values. That is called precision. Accuracy means if any particular value is there. For example, if any theoretical value they will give, like charge of electron is 1.6 into 10 raised to minus 19 coulomb they will give. You are doing an experimental value. That experimental value have 2 or 3 readings. Or you may say, gravitational force is 9.8 meter per second. Correct? 9.8. Acceleration due to gravity is there, no? That is 9.8. That is the theoretical value. So if you observe with respect to stone, with respect to that paper, okay, you are getting different values. Understood? Different values. So, but that you may get 9.79, 9.76, 9.81. So these are all the approximate values. Okay? So these values which are nearer to the true value, that is accurate value. What is precision means? These two are precision. If 9.82 is there, these two are precision. Very closeness with the respective value. Okay, precision means closeness to the value of among each other, not with respect to the true value. Okay, accuracy means the agreement of the value with the true value. Agreement of the value with the true value. Okay, I'll give one example, then you'll understand. So listen, assume a theoretical value you want to obtain is 2. Okay, 3 students are there, A, B and C. So first result and second, 2 trials they will do. So student A get the values 1.95 and 1.96 and 1.94 and 1.96. True value is what? 2. And this one, B get 1.96 and 2.04. Okay, next. Next, this one will get 1.99 and 2.01. That is student C. Okay, so the theoretical value you want to get is 2. Okay, the students A, B, C did the experiment of 2 trials. So student A got the reading 1.94 and 1.96. They are very close with each other. 1.94 is nearer to 1.96. Of course, these two are precise. These two are precise, means they are very close to each other. But with respect to 2, they are far away from each other. Okay, with respect to 2, they are not the nearest value. So, they are precise but not accurate. They are precise but not accurate. Understand? They are close. Their values are close with each other. They are precise, but they are not. These values cannot be agreement with the true value. So that's why it is not accurate. Understand? Next, this one. Of course, 1.96 is there, 2.04 is there. They are not at all precise. So they are not precise and as well as not accurate, because from the true value also they are very far. They are completely different. Okay. So students, this one is 1.99 and 2.0. Of course, these are precise. Correct? Because 1.99, 2.01 only, they are very close to each other. Only one term is between them. Understood? So next, of course, 1.99 is nearer to 2 and 2.01 is also nearer to 2. That means they are precise as well as accurate. Means if you add and subtract this, you will get the exactly average. 1.99 plus 2.01 means you will get 4 by 2, that is 2. Average of this. So these values are what? Yes, this value is going to agreement with the value of the agreement with the true value. This is what? Precision and accuracy. Precision means closeness with respect to the respective readings, not with the true value. Okay? Accuracy means the agreement value with the true value. Understood? So this is the example for accuracy and precision. So students, the next one is significant figure. So this significant figure has some rules. First I will say the rules, then I will give example. Okay. So first rule is significant figures, which is very important for one rule. Okay, they'll give some value like 2.005 something. In that, they'll told you to count how many significant figures are there. For 1 month, very, very important. Okay, students, the first rule is all non-zero digits are significant. Yes, they are considered. All non-zero digits except 0, all are what? 100% significant figures. There is no doubt in that. Understand? Next, zeros preceding non-zero term or a non-zero digit are significant. Okay, I'll write only this one. Forward, you understand? All non-zero digits are significant. Zeros preceding a non-zero digit. Zeros preceding a non-zero digit is not significant. This one is significant. Okay. So 0 preceding non-zero digit is not significant. Understood? Later I will give example. Next. Zeros after decimal point. Zeros after decimal point are significant. Zeros after decimal point are significant. Okay, especially zeros after non-zero digit as well as, I'll write here, after non-zero digit and decimal point, both are significant. Okay, and next, the definite value has infinite significant figure. Infinite significant figures. Okay, next, zeros between two non-zero digits are significant. Okay, for all these, I'll give one example, then you will easily understand. Okay. So students, all non-zero digits, how many zeros are, we don't bother about that. Okay. So here point is there, then also here 0 is there. All are non-significant. Means if this type of number is there, 0.0001 like this, understand? Then this is, the number of significant figures is again 3 only. Why? Because, so this decimal point zeros represent position. Like we can shift this point from year to year, like 1, 2, 3, 4, 5, 6. That is 2.65 into 10 to the power of minus 6 we can write. The 10 to the power of minus 6 means what? This is divided by 10 raised to minus 6 times. So that tells about what? Position, whether it is in a first position, unit place, 10 place, or 100,000 like that. Okay, so this one, the 0 preceding non-zero digit is not significant. Okay, so any zeros like 0 point like this is the anything. So that is what? Non-zero. Understand? Next here, zeros after non-zero digit and the decimal point are significant. So students, instead of this 0, if 1 is there. Okay, so this is a non-zero digit. After this, how many zeros are there? All are significant. 2, 4, 5. Then I will write the same example here. Instead of 0, I took 1. So here the significant figures are 1, 2, 3, 4, 5, 6, 7, 8, 9. Understood? So here 9 significant figures. Here only 3 significant figures. Understand, students? And here also listen, zeros between two non-zero digits are significant. This is also a non-zero. This is also a non-zero. In between this, zeros are there. Of course, they are significant. Understood? And another one I will give. If 100 is there, okay, in 100, the significant figure is only 1. This one. Okay, if you put point here, then the significant figures are 3. Are you getting? If there is no point, this can be written as 1 into 10 raised to 2. So of course significant figure is 1. If you write point here, point means what? Of course there is a next numbers here. Those are 0, 0, 0. We cannot count, but then also these become significant. Understood? So this is 100 means significant figure is 1. Okay, if point is there, then the significant figures are 3. Are you getting? Next. Next, the definite value has infinite significant figure. For example, 2 balls are there and 20x are there. 20x may be written as 20.00000000. How many zeros we put, we won't bother about it after point. Okay, that means if the digits after this we are considering them preceding terms, this is a non-zero term, we are putting 5 here and zeros are there. So those all zeros are significant, that means infinite significant figures. If they give any one value, definite value, if they give 100 point with a decimal point, then the value is 3. Okay, significant figures is 3. If they give simply a 20 points, 20x are there, then how many significant figures? You can't count only one. Significant figure 2 is there, that is non-zero, 1 is the correct answer, that is wrong. It is a definite value, means it has infinite significant figures. Because after decimal point, we may write so many zeros, and those zeros are significant. For definite value, I am telling you. Okay, not indefinite. So these are all significant figures. Means the thing is all non-zero digits are significant. 0 preceding non-zero is non-significant. After the non-zero digit is significant. In between the non-zero is significant. Understood? Understood. Okay, decimal point I said, if the definite values are there, then they have infinite significant figures. Okay, among these they'll give the answer. Means they'll give 1.25 is there multiplied by some any other value 3.25 etc. Multiply this 3.2 etc. Multiply this. Okay, write the value. So what is the answer and how many significant figures are present in the respective answer. If you multiply this, you get some answer. In that answer, how many significant figures are there, you have to calculate. That is for 2 marks. If they give this type of any one number and told you to write the significant figure means, that is 1 marks question. If they give multiplication or subtraction or addition, anything. So in that answer, how many significant figures are there? That is for 2 marks. Okay, that means in this significant figures also addition, multiplication, subtraction and division is there. Okay, and there is a rule for that. Okay, what is that rule? I will say. Are you there? Are you understood what are significant figures? Okay. So in this addition, subtraction, multiplication and division. I will give one example, then you will easily understand. Okay. So listen. Here students, 12.01 is there. 18.15. 1.1. Okay, addition is. If you add this, you will get 1.1 means this is 1.10 like this. Okay, you simply take 1.1. Students here, it is 5 plus 1 6, 1 plus 1 2, 8 plus 2 10, 11 1. That is 31.26. Correct? But the answer is not 31.26. Here you have to check how many significant figures are there in this. Here the significant figures are is how much? 4. This is 1, 2, 3, 4. Here the significant figures is 1, 2, 3, 4. Correct? Here the significant figure is 2. Always the answer should be written in minimum significant figure value. Understand? Here the minimum significant figure is 2 means we have to consider only these two digits. So the answer is 31. Understood? Always the answer should be written in the term which is getting a minimum significant figures. Among these three, this one having less significant figure, that is how much? 2. So the answer should be in the 2-digit form. That means the answer must consist of 2 significant figures. Understand? Okay. So the next one is then. Students, if you have, what is the answer you'll get? 6 plus 3, 9, 5 plus 2, 8, so 7, okay, 5 plus 2, 7, 2, 1, 127.79, okay, next, here the significant figures is how much? 3, that is 1, 2, 3, here the significant figures? 4, here the significant figures? How much? Not 1, here point is there. Point is there. 3. Yes, 3. That's why I wrote that. Okay? After decimal point, the zeros are not countable because they tells about the position. Okay? But here, 100, that is significant because here decimal point is there. Understand? So 3. So which is the minimum significant figure is 3. So answer should be 3 digits. That is 127. Okay, so your answer is 127. Actually, this is not the correct answer. Just I am telling you. Later, rounding up of the figures. For example, 35.5, you take it as 35. 35.9, you take it as 36. What is the reason for that? How we have to round up? I'll say. Okay, next. Multiplication, I'll say. 12 into 10 to the power of. Remember 12 into 1.. 1.44. 12 into 1.44. If you multiply that, you will get the answer. This one is good. Right? So after 1728, right? So here, after 2 digits, point is there. Here I can write. Okay, students, here the number of significant figures in 12 is how much? All non-zero digits are significant. Correct? Here how many significant figures are there? 12, 2. Okay, here? Yes, 3. So answer should be present, written in which form? Either, how many significant figures should answer consist of? 2, because less number of significant figures must be the answer written. Okay, so here 2 is there, that is 17 is the answer. You are considering like 17. Understand? Similarly for division also. If you divide 12 divided by 0.3. Okay? Answer is 40. Correct? 12 divided by 0.3. Answer is 40. Don't take that. Listen. 12 is there. 0.3 written is 3 into 10 to the power of minus 1. 3 ones are 3 fours are. Minus 1 go to the numerator means it is 10. 4 tens are 40. For each and everything you can't use that calculator. It is a simple mathematics. And for you, for complex calculation also in need, you won't use that calculator. They won't allow. Not even earrings they will allow. Not your pen, not your paper. Everything is provided by NEET Academies only. Means if you are conducting the NEET exam, they will only provide everything. Understood? You can't wear jeans also and not full sleeves dress. So in that you can't use calculator. So be accurate with the calculations with a calculator. Understand? So this is what 40. 40 means here the significant figure is 2, here the significant figure is 1. The answer should be presenting only one significant figure. Here all non-zero digits are what? Significant, but this is infinite. Answer should be written in significant means it is 4.0 into 10 to the power 1. Like this. Understood? Okay. So this is all about the multiplication, subtraction, addition, subtraction, multiplication and division. The thing you remember, so in all addition, subtraction, multiplication, division, count the number of significant figures in the given digits. Which one is having the less number of significant figure at that much of answer. Significant figure must be present in the answer. Least significant figure value corresponds to the answer. Understood? They should be resembled with the significant figure. So students here, remember here 26 is there, here 79 is there, here 28 is there. Okay? So in this, if such a type of values are there, then rounding up of the significant figures takes place. Understand? Rounding up of significant figures takes place. For that, 3 rules are there. One is, if the last term is, if the last term is greater than 5, then the preceding term is increased by plus 1. For example, 12.6. This last term is greater than 5. So this is considered approximately as 13. Okay, next, if the last term is, I'll take this one only, less than 5, then the preceding term written as it is. Okay, next, if the last term is equal to 5, 12.5 is also there, 11.5 is also there as well. If these last two terms is equal to 5, at that time, observe the preceding time. If it is even value, write it as it is. If it is an odd value, then add plus 1 and write it is like 12. If it is greater than 5, add 1 to the preceding time. If it is less than 5, write the preceding time as it is, whether it is odd or even. If it is equal to 5, if before the preceding term is even, it is written as it is. If the preceding term is odd, then it is added to with plus 1. Okay, I'll give the example here. 3.056 is there. Okay, so if you want to round up this figure with the 3 significant figures, here 4 significant figures are there. You want 3 significant figures. So the last term is neglected or removed. By how? 3.0. Here it is greater than 5 means what we have to do? We have to add 1 to the preceding term. It becomes 3.06. Okay, I'll type this one again, 3.053 or 054. Okay, so here we want to write it in a 3 significant figures. Then the value become what? 3.05. Okay, this is in what? 3 significant figures. If listen students, it is 3.055. This 5 is equal, the last term is equal to 5, but the preceding term is an odd number. Then it is 3.06. Then this is having 3 significant figures. This is the question they will ask. Write the given term in a 3 significant, the given answer in a 3 significant figure. It consists of 3 significant. So if you want to do it for 2 significant figure, 2, okay? So 3.06 is there. You have to eliminate this one. Then it becomes, if you want to eliminate 6, it is greater than 5. Then the answer is 3.1. Because if any term is greater than 5, preceding term is added or increased by unit 1. That is 3.1. Here 5 is there. Is equal to 5. You know 0 is a even number. 0 is considered as even, right? Okay. That means the answer is 3 only. Here also 6 is there, so answer is 3.1. So 2 digits means you have to write as 3.0. Understood? Okay. So this is all about how to write and how to calculate, how to round up the values in the significant figures. Scientific notation means representation in n into 10 to the power of plus or minus n form. Significant figures means the numbers we are going to consider for the value as a considered value. Okay, in that in the multiplication, addition, subtraction and division, we are going to consider the given answer should be written in the value or the digit which consists of a less number of significant figures. Answer should be present in the digit which are going to add, multiply, divide and subtract. In that problem, the digit or the number which consists less number of significant figures. In that significant figure value, the answer should be represented. To represent that value, we want, listen here, we want to represent it in a 3 digits value. Okay, here 79 is there, that means it is written as what? 127.79 is there. We have to eliminate last term, then it will become what? 8. Again we want in a 3 significant figure, means we have to eliminate 8. Then this become what? 128, because this is greater than 5. The answer 127.79 is approximately equal to 120. The value of this, the exact answer of this is 128, not 127. Understood? The correct value, the accurate value with the two values is 128. Why I explained, are you getting? So we have to put the answer in the significant figures which is present least in the digits. Here least is 3, but the answer we got is 5. Initially we round up for 4, initially we round up for 3. Understand? This is all about the significant figures. In the tomorrow's class, we will discuss about the dimension analysis and the law of chemical combinations. Okay? Thank you.